In this video, we will start with R formula. You will find this on page 455 in the Namibian AS-Level Mathematics textbook, Y equals mx+c to success. R formula. In physics, when two wave motions are superimposed on each other, we can come across expressions such as a sin theta plus b cos theta, where a and b are real numbers. It is useful to express a sin theta plus b cos theta as a single term. There is two terms, but as a single term, it can be expressed as r sin theta plus alpha. Okay, so r sin theta minus that alpha, or r cos theta plus alpha, or r cos theta minus alpha, so it's either sin or cos. Okay, so the formula for replacing this, say for example, a sin theta plus b cos theta by this r sin theta plus alpha is derived as follows. Okay, and I'm going to show you how we come across the formula. So derive this from this. Okay, so let's start. Let's start with this statement, and I can just show you here. Okay, so we start there, where r is a positive constant and theta is an acute angle. Okay, so using the compound angles, we're going to prove this. Now, you remember the formula for compound angle on the right-hand side of the equation. So just use this right-hand side. So I'm rewriting the right-hand side there. Then I think of compound angles. So it's going to be r sin theta cos alpha plus cos theta sin alpha plus. And if we're going to multiply the r in, we're going to get this. Okay, so therefore, we express this basically now, this one, there it was, and we express it as this. Okay, so now we're going to go back to this and we're going to say, okay, so that, do you see it's exactly the same as stands there, is equal to this blue now. The one here on top, what we express. So, now we are going to equate the coefficients of sin theta. Now, can I just show you? If there is sin theta, there is sin theta. So I can say that this A is equal to R cos alpha. So A is equal to R cos alpha. And if I have to take another one, I hope it's going to work now, I'm going to say B, there is B, and that is going to be equal, do you see the cos? So it's equal going to be to R sin alpha. Okay. So basically I just equate, and so I look what is with this term and I look what is with this term. And there is my two new equations. And now I'm going to say equation 2 divide 1. Why do I say equation 2? Because I'm trying to get tan and not cot. And if I want to get tan, then sin must be on top. So that's why I say 2 divide 1. So then it's b over a equals sin alpha divide cos alpha. And then tan alpha is equal to b over a. Because sin over cos is tan. Okay. Now I'm going to square 1 and 2 and adding them. Equation 1 and 2. There is 1, there is 2. So if I square everything, now it's like I square both equations. Now, can I show you? If you square this, you're going to get a square is equal to r square cos square alpha. This is going to be b square equals r square sin square alpha. And now I'm going to add it up. So if I'm going to draw a line, so I'm going to say a squared plus b squared equals r squared cos alpha plus r square sin square alpha. Okay. Then I take r square out as a common factor, and I'm ending up with this, and this is an identity. Cos square alpha plus sin square alpha is equal to 1. So basically, I'm ending up with a squared plus b squared is equal to r squared. And now I take just the positive square root. So it's actually if you take the square root plus minus, but I'm interested in the positive one. Okay, so therefore, sin theta plus b cos theta can be written as r sin square theta, okay, do you see, plus that exactly what I got there on top, where r square is then this a square plus b square, the square root, and tan theta is equal to b over a. Okay, so how you will find that to express, so that is to 2 that I'm going to find something in. But sometimes, as it's better, I'm going to show you the other way, one, and then I'm going to show you an example. Then it's always better to understand the formula, how we derived it. So if we derive, can I just go back? So in the case, this one was just a plus, do you see? Where this one is now just a negative, do you see? So then this is going to be a, and it's just instead of a plus, it's just going to be a negative. Where written as this, where r is still this, and tan alpha is still this. And this is just my two formulas. Do you see? So basically, I think the white line just did not go through there. Okay. So basically, if I have this is equal. So if I follow the positive, this is positive. If I follow the negative, then this is negative. And this is what is r, and this is what is tan alpha, b over a. Okay, let's look at an example and see how we're going to use this. Okay, so express 8 sin theta minus 15 cos theta in the form r sin theta minus alpha, close the bracket, where r is bigger than 0, do you see? And alpha is bigger than 0 and smaller than 90, so it's an acute angle, giving the exact value of r and the value of alpha correct to 2 decimal places. So we're going to express it in this. Let's start by using this statement. Okay, so we want to express it in this form. So this is equal to this. But remember that this is now what I showed you in the previous one, that I can derive, and by making use of compound angles, I can get this. Okay, so I replace this by this. Now, equating the coefficient, so I get 8 is equal to r this, and 15, you don't have to, you can ignore the sign because it's negative. 15, that's also a negative. So 15 equals r sin theta. So basically, I was just looking, just like I showed you in the, there's the sin theta, there's the sin theta. So basically, I can say 8 is equal to this. 8 is equal to r cos alpha. Okay, and then the next one, I can say, let's just make it, there was the cos, so I'm going to say, sorry, I want to show you the cos here also. So I can say then that 15 is equal to r sin theta. Okay, and then I divide the equation. Remember, 2 divide 1 because I want to get tan, and there I get my angle. That's the first, my acute angle, alpha, 61.93. As they said, 2 decimal places. But I'm not done. I must still get the value of r. So squaring and adding the coefficients. So remember what I showed you in the previous one. If you square this one, so don't forget, I'm not showing you here. I'm just making use of that principle. So it's 8 squared is equal to r squared cos squared alpha. And this is 15 squared is equal to r squared sin squared alpha. And if I square it and I add it, can you remember, and I take r squared out as a common factor, then I get cos squared alpha plus sin squared is 1, but I'm ending up with 8 squared plus 15 squared is equal to r squared. And now I can basically just find the positive value because r is bigger than 0. Okay, so r is 17. So if I have to substitute two things. I must find the value of r, and I must find the value of the acute angle alpha. And that's what I substitute. Okay, so express it in that form. Okay, where you find r and you find this alpha. Now I'm going to use it. So hence, I'm using this answer of A, solve the equation. So I'm starting with this, but now I know that, can I show you again here? I'm just going to clean so that you see a little bit better. As I said to you, this is equal to this. Okay, and now I'm saying again the green, do you see there? But now I'm just going to put the 14, okay? But in the place of this green, I can now put the blue, and I can put the value of r in. I have the value of r now, and I have the value of alpha, the acute angle, and I put it in. Okay, and then I divide 17, and now I can use chapter 4. Okay, I'm back at chapter 4. I'm going to solve that, and don't forget it's between 0 and 360. But don't forget that you have to change your domain now, because this is theta, and I'm sitting with theta minus 61. Now, how did I come to that? Basically, I was just taking theta. It was like this. And then I was basically just subtracting 61.93. Subtract 61.93. Subtract 61.93. Okay, and then I got this negative, I got this, and if I subtract, I got this. Okay, and now basically it's just showing you it can go to the negative, and then it goes from there up to there. That value there, 298, if you subtract that. Okay, but if I'm looking, sin is positive, so it's not going to influence this, because sin is positive in quadrant 1 and 2, and there I showed you. Then I find the basic angle, so press shift sin, close bracket, 14 divide 7, close the bracket, approximate also to 2 decimal places, so that your answer is correct to 1 decimal place. And then you just, in this quadrant, it's just this, it's just the angle, and in this quadrant, it's 180 minus that basic angle. And then I can, at the end, add that 61.93, and I add that 61 point. After I subtract, I add, and I get my two values. So basically, do you see there? This is my two answers correct to 1 decimal place. That's how you do it. Okay. I want you to stop the video, and it's really just getting you used to the basic, and I want you to do number A as well as number B. Again, you can continue the video as soon as you are finished. Okay, let's start. Number A. Express this in this form. So I'm still with the negative. So if I'm doing this one, I'm just going to start by saying 9 sin theta minus 12 cos theta, and then I must express it as r, where I find the value of r, sin theta minus alpha. Okay, where r is bigger than 0, theta is acute angle, give the value to 2 decimal places. Okay, so remember what I did, and I'm just going to move it a little bit. I know I'm making use of compound angles, so I know, and I'm going to write this one a bit longer. Maybe in the next ones I will write shorter, but just to get you used to also how I derived it. So it's sin theta, compound angles, cos alpha minus, okay, I can first even put this, okay, minus cos theta sin, I'm moving it still, sin alpha, whereby this is going to be r sin theta cos alpha minus r cos theta sin alpha. Okay, now I'm going to do the equating. So if I'm going to equate, there is my sin theta. So therefore, this is what I'm going to equate. So therefore, I'm going to say 9 is equal to R cos alpha. And then I do the same with the other one. The signs are the same, so leave the sign out. So there is cos, there is cos. So I'm going to say that this, there I'm going to equate. So I'm going to say that 12 is equal to R sin alpha. Okay, this is equation 1. This is equation 2. And then what am I going to do now? Now I'm going to say equation 2 divide by 1. Why? 2 divide by 1. Because I want to end up with tan, and that will be sin divide. So basically, 2 divide by 1 is going to be, as I said to you, I'm doing it a little bit longer. So it's R sin alpha divide R cos alpha, and on the other side it's 12 divide 9. So the r's cancel, so I'm sitting with tan alpha is 12 over 9. And now I can take my calculator, make sure it's on degrees. So say shift, and then I go tan, and I go bracket, 12 divide 9, close the bracket, equals, okay, let's just see, mine was not on degrees, I used another one, it was on the degrees. Okay, so let's just go to degrees. So it's going to be shift, tan, bracket, 12 divide 9, close the bracket, equals, so alpha is equal to 53.13, 2 decimal places. Correct to 2 decimal places, they said there. But now I must still find the value of R. Now, how do I do that? I'm going to square both equations, and I'm going to add that up. Just like I said here. Square, and so I'm just going to say here to you, square and adding equation 1 and 2. Okay, so basically this is going to be then, can I just do it in white again? So it's 9 squared plus 12 squared is equal to R, I'll do it again longer, R squared cos squared alpha plus R squared sin squared alpha. Okay, if I move it up, then I'm just going to get on this side R squared, I'm showing you again. So it's cos squared alpha plus sin squared alpha, and that is going to be, so therefore 9 squared plus 12 squared is equal to R squared. But now I'm taking the square root, but they told me in the question that R is bigger than 0, so just the positive. So actually it is R equals plus minus the square root of 9 squared. Just get the pen correct. 9 squared plus 12 squared, but R is bigger than 0, so therefore R is positive. And I'm doing it long just for the first 9 squared. Sorry, I've got the square there. And then if I'm pressing that on the, what is this? 9 squared. So it's 9 squared plus 12 squared. It's 225. And that is going to be, if I take the square root, it's 50. Okay. So now I have R. And now I can go on. So I'm going to say, therefore, remember my beginning statement. Can I just start here? Can you remember that beginning there? Okay. So I'm just going to substitute R, and I'm going to substitute alpha. So therefore, I'm going to do it in red. So therefore 9 sin theta minus 12 cos theta is equal to 15 sin theta minus 53.13 degrees. And that is my answer of A. Let's just go back to the question. The question is stating, here is the question, give the value of alpha corrected to decimal places. So I substitute now, solve the equation, and theta is between 0 and 360. So I'm going to do B here because I need some of that information. So let's just start with number B. So I know from the beginning, like I said there, 9 sin theta minus 12 cos theta is equal to R sin, is equal, can I just show you, is equal to 4. They said it here. Can I show you? There is equal to 4. Do you see there? I'm writing that. Let's go on. So that is equal to 4. So now I can, because I know of this statement, I can now basically say, do you see here? This is equal to this. Okay? So in the place of this green, I can write now that, so therefore, due to the top statement, I can say 15 sin theta minus, I'm sub the R value and the acute angle. So basically, I just, in the place of this, I just substitute my answer of A and I keep the 4. Now I'm going to simplify. So it's going to be sin and that's going to be 4 over 15. Okay. And now I can I show you if I'm drawing a sketch again? I can just show you here. Okay. So basically, if I'm looking at this, then I can just say, okay, remember theta, can I show you here? I want to just show it to you here on top. Theta is, let's just go back to the question. I can just show you here. Do you see there? That is the statement I'm writing. So theta is smaller than equal to 0, bigger than equal to 0, smaller than equal to 360. So if I want to get this statement, then I subtract 53.13, subtract 53.13, subtract 53.13. So basically, I'm getting that negative 53.13, and I'm going to get 360 minus 53.13 equals 306. 6.87. Okay. Now, basically on this sketch, if I have to indicate it on this sketch, I can indicate it like this. Let's just use green. Say, for example, so this will be 53.13 in a negative. The other one will be like this, which will be the positive 306.87. But if you see, it's not going to influence this question. The reason why, where is sin positive? Sin is positive in the first quadrant and in the second quadrant. So it's not influenced by this. Right. So first I'm going to just find my basic angle. How do I find this? I say shift sin and then I go bracket 4 divide 15 close the bracket, equals, and that's going to be 15.47. And now I'm going to get my two answers. Remember, this is one, and that, oh, sorry, it's a little bit long. And that is the other one. So for the one, it's just going to, oh, sorry, you cannot say theta. You have to repeat this y. 53.13, that's what's theta, is equal to the angle. So what is that? 15.47. That's my first answer. And my other answer is theta minus 53.13, and that is going to be 180 minus that 15.47. So that's my one answer, that's my other answer. Right, then I just simplify. So take your calculator, press 15.47 plus 53.13, approximate to 1 decimal place, and that will be theta is 68.6 degrees. And then this theta is going to be 180 minus 15.47 plus 53.13, and that is going to be 217.7 degrees. And that is your answer. So therefore, you don't have to say, I just do it for the video's sake. So it's 68.6 degrees and theta is 217.7 degrees. That's your answer.